Okay, now we will talk about if we have nth order constant coefficient homogeneous differential equations, how we can solve them. So far we talked about the first order, second order, and now we will generalize what we have known. Let's see in here. This is our nth order differential equation general form. As you can see, this is an nth derivative. There are coefficients that are constants. And again, we will be looking for the solutions as an exponential form like that, e to the rt. And once we plugged in here, as you know from the second order differential equations, we were finding the characteristic equation. And the same way, we will find a characteristic equation for the nth order differential equation, but this time our characteristic equation will be nth order polynomial. And we need to find the roots of this nth order polynomial. Once you find the roots, other than that, it's parallel what we have done for the second order one. If we have distinct roots, we will write them distinctly as the power of an exponential. If we have repeated ones, then the second one is gonna be t times e to the rt. And if we have complex conjugate ones, we have e to the alpha t plus cosine beta t, e to the alpha t plus sine beta t. You know it from the last class. And exactly, look at that. This is the fourth order differential equation and second order and the y term. And if I put e to the rt in here, I will find the characteristic equation. Let's do that. And let's determine four solutions because we have fourth order for this differential equation. And we will check if they form a fundamental set of solution. And you know that we have been checking this by looking with the Wronskian determinant, and exactly we will be doing the same thing in this section. Firstly, let's plug in e to the rt. Once you plug in e to the rt, for the fourth order derivative there will be r to the 4. For second order, 10 was given, 10r squared plus 9. And if you factor out e to the rt, this is the polynomial you need to solve. Since this is second order, fourth order, but there is no third order and first order r terms, you can easily factor out by r squared minus 9 and r squared minus 1. And in here you will have plus or minus 3, and in here you have plus or minus 1. So you have all distinct roots. If you have all distinct roots, the solution is so straightforward. Just plug in the roots as the powers of the exponential in here, e to the t, e to the negative t, e to the 3t, e to the negative 3t. So to be able to say that they form a fundamental set of solution, we need to check the Wronskian of these four solutions. And you know how we were doing. We were writing the solutions here, and now instead of taking the first derivative, for second order one we need to take first derivative. For fourth order one you need to take the derivative until 3. So you need to take 3 times. You need to get 4 by 4 matrix. So for nth order one, you need to take the derivative until n minus 1. Okay? So once you do this, all the derivatives of e to the t is e to the t. The first derivative of e to the negative t is negative e to the minus t, and plus and minus. And in here, each time there will be 3 is coming as a coefficient. And in here, again, the sign is gonna change and the 3's will be coming. And here you go. This is your determinant. To be able to solve this determinant, what we need to, for the first column, since e to the t is the common factor, I can just take that one out. Second column, e to the negative t. Third one, e to the 3t. Fourth one, e to the negative 3t. And since these are multiplication and the bases are same, you can add the powers, e to the t times e to the negative t, e to the 0, which is 1. And in here also you will get 1, so the coefficient is 1. And now you need to find the determinant of this 4 by 4 matrix. And you know how to do that. You need to do the Gaussian elimination. You can put this matrix in a triangular form. Once you have the triangular form, the determinant will be the multiplication of the diagonals. So this is the easiest way to do that. That's why we need to make all those 3 terms 0 by doing multiply the first row by negative 1, add to the second, add to the third, and add to the fourth. Exactly, I showed in here. You will get this matrix, and now this is your pivot. You need to make this negative 2, 0. That's why we need to multiply the second row by negative and plus the fourth row. You will get the new row 4, And here you go. And now you need to get rid of this 24 by multiplying the third row by -3 and add to the fourth one. And here you go. This is what you will get. And once you have a triangular matrix, the determinant of this 4 by 4 matrix will be the multiplication of these diagonal elements, which is 768. And as you can see, it is not 0. Since this is not 0, you can say that this 4 solution forms a fundamental set of solution for your differential equation, and this is the general solution of your differential equation. Okay? I hope you understand that. You need to make sure that you remember how to take the determinant of n by n matrices. The one way is cofactor expansion, another way is doing the row operations, turn your matrix into a lower triangular or upper triangular matrix. Once you have it, you can just multiply the diagonal elements and you can find the determinant of your matrix. Okay? This is another example. Now we have third order differential equation. You know what order means. Order means the highest derivative inside the equation. And here you go. This is 3. That's why we have third order differential equation, and we can write the characteristic equation by 2r cubed minus 4r squared minus 2r plus 4 equals 0. So this is third order polynomial, and we need to find the roots of that. If you can factor out like that, by first I divide this one by 2, so my r cube, you have r cubed minus 2r squared minus r plus 2 equals 0. And you can factor out r squared in here, and in here you will have r minus 2. So if you factor out r minus 2, you will have r squared minus 1 times r minus 2, as you can see here. You can factor out like that. But if you cannot find the factorization like that easily, you can use synthetic division. And of course also you need to check the possible roots, okay? I will talk about that, but since you can factor this one out, you know that r equals 2 is one solution, another one is plus or minus 1. So your solutions will be e to the 2t, e to the negative t, and e to the t. But let's say you couldn't find the roots of this one. How do you find it? You need to check the possible rational roots by looking for p over q. What is p over q? P is the factors of 2, and q is the factors of a0, which means that the highest terms coefficient. So what are the factors of 2? 2 can be divided by 2, negative 2 plus or minus 1. And since q is 1, the highest derivative coefficient, then the possible factorizations for that one is plus or minus 1. And all possible p over q is plus or minus 2, plus or minus 1. So these are going to give the possible roots of your polynomial. So you can start by checking that. Check check r equals 1. Once you plugged in r equals 1, you will see that this is the root. You know that once you plugged in 1 minus 2 minus 1 plus 2, it's going to be 0. So r equals 1 is a root. If r equals 1 is a root, then r minus 1 is your factor, right? And after that, what you can do to be able to find the other part of the second order part of your factorization, you need to put, you can use synthetic division by to be able to find that. First, I put the root that I found in here, and these are the coefficients of my equation. What are they? Look at that. 1, negative 2, negative 1, 2. 1, negative 2, negative 1, 2. And after that, what you need to do, you need to put this 1 here, and 1 times 1 is 1. Put it in here, add them, negative 2 plus 1, negative 1. Negative 1 times 1, you are always multiplying with the 1 that you found as a root, which is negative 1, you put it in here, add them, negative 2. Negative 2 times 1, negative 2. Once you add them, 0. And these are going to be the coefficients of the remaining polynomial. In here, you know that one factor is r minus 1. Another one is r squared minus r minus 2. And in this one, you can easily factor out by r plus 1, r minus 2. And here you go, you can find the roots easily, okay? Or what you can do, once you find the first root, you can do the long division and you can find the other factor and you can factor it out again, okay? And by this, you will just put it as a power of an exponential and you need to write the general solution. Of course, you need to check the Wronskian for that. Once you check the Wronskian, these are my solutions. I took the first and second derivatives. I factor out the common exponentials out. We will have e to the 2t there. And for this determinant, you will get 6. And 6 times e to the 2t is not equal to 0. Then you can say that they form a fundamental set of solutions. Okay? It is that easy. Of course, there are other roots you can find, like other than repeated roots or the distinct roots, you can get complex conjugate roots. And this is just one example. Look at that. This is fourth order differential equation. And once you write the characteristic equation, you have r to the 4 minus 4r cubed plus 10r squared minus 12r plus 5 equals 0. So fourth order polynomial you need to solve. And it will help if you know one factor. And we to be able to check the p over q, we can do that. Look at that. This is our p, this is our q. Q is 1, p is 5. And all factors of 5 is plus or minus 1 and plus or minus 5. And all factors of q is plus or minus 1. P over q will be plus or minus 1 or plus or minus 5. So let's check that. 1 is 1 the root plugged in here. And yes, it is a root. Then r minus 1 is a factor for this equation. So to be able to find the remaining third order polynomial, I will use synthetic division. Now I put my 1 in here, the root that I found according to the p over q. I put it in here, and now I just move the first coefficient in here. These are the coefficients: 1, negative 4, plus 10, negative 12, 5. I move the 1 out. I multiply with 1. 1 times 1, 1. I put it in here. See? I add them, negative 3. Negative 3 times 1, negative 3. Add them, 7. 7 times 1, 7. Add them, negative 5. Negative 5 times 1, negative 5. Add them, 0. So here you go. This is the third order polynomial's coefficient. So for the 1, I wrote r minus 1. And for the remaining, 1 times r cubed, negative 3 times r squared, 7r, negative 5 equals 0. Okay? And in that one, you can check p over q again. And again, all possible roots are plus or minus 1 or plus or minus 5. So let's check 1 again for this part, r cubed 1. It will be 1 minus 3 plus 7 minus 5. And this is 0. Yes, r minus 1 coming twice as a root, it seems. So I have r minus 1. And what are the coefficients of this third order polynomial? 1, negative 3, 7, negative 5. I put in there. And I moved 1 down. 1 times 1, 1. I add them, negative 2. Negative 2 times 1, negative 2. Add them, 5. 5 times 1, 5. Add them, 0. And now these are the coefficients of the remaining second order. It was fourth order at the beginning. Remember that. Then I found one factor, 1. I found the third order polynomial. I found another factor, 1. I found the second order polynomial right now. And in that one, it is r squared minus 2r plus 5. So I have 1 twice as a root. And in that one, I can use the quadratic formula. And I can find the complex conjugate roots. So what are the roots? R1 is coming twice. And R1 plus or minus 2i is another 2 roots. So I can write the solutions. One solution is e to the t, another one t times e to the t, and for this e to the t cosine 2t, e to the t sine 2t. And here are the fundamental set of solution. Make sure that check the Wronskian of that one. You will see that the Wronskian is 16 e to the 40, which is not 0. And you can write your general solution as a linear combination of that. Okay? This is how you can check the Wronskian. Make sure that you do it and you understand well. Okay? And let me show you one more example about that. Here you go. This is the fourth order differential equation. And once you factor out, you can get roots as plus or minus I, 4 times. So what you are doing, the first root is going to bring you cosine t and sine t. Another one is going to bring you can think like a repetitive roots, t cosine t and t sine t. Because there is no real part, there is no exponential. We have only cosine and sine solutions, okay? And you can, this is just the one example. If you have a characteristic equation, something like that, r equals 3 is multiplicative 3. And for the roots for multiplicative 3, if one solution is e to the 3t, another one is going to be t times e to the 3t, another one is t squared times e to the 3t, okay? And this is going to bring you e to the negative t, and this is going to bring you t times e to the negative t and t squared e to the negative t, okay? And if you have another one, t cube, it will be going like that. You can see in here, okay? I hope you understand it. And this was the end of the nth order differential equations.